Section 4.2, we've got to do some skill building here to get ready for what comes next. And we need to spend a little time with what we call summations. And in order to deal with summations, we need to deal with our old friend sigma. Greek letter, and it has always got something to do with a summation. A summation. Yahoo! Yippee! Some of you get excited about this, some of you maybe don't. So what this really means is we've got ourselves the sigma notation. So sigma always has a counter. So this thing, this I, we call it I for index. It can be whatever you want. It's the thing that is going to reset itself every time and generate your sequence and ultimately your series of numbers. So there's your index. 1 is our starting value. N is our ending value. And A sub I is our term generator. Our term generator. Okay, so what does that mean? So we start with the counter. The counter is placed at 1. The 1 is placed in place of the I in the term generator. So what's the first term going to be? It's going to be A sub 1. We then repeat the process. We take the counter. We move the counter up by 1 value. It's now 2. It gets placed into the term generator. What do I get? A sub 2, A sub 3, da, da, da. I keep going until I've put N into the term generator. And that's how I know when I'm finished. So the first term has the term generator with the starting value plugged in. The last term has the ending value plugged in. And we'll get to the calculator piece in just a second. What I want to do is kind of tie this in a little bit first. So this first example, sigma, my counter gets placed at 1. So I is my counter. It starts at 1, and it's going to go until I put in 6. So what is this term really going to look like? Well, my first term, put a 1 in place of the I. Second term, put a 2 in place of the I. Third term, put a 3 in place of the I. Fourth term, put a 4 in place. 5, 6. Why do I stop at 6? Because it says my last value that I'm going to plug in into my term generator is going to be 6. Now you take those and you can add them together. Fast way to add those together. 1 plus 6 is 7. 2 plus 5 is 7. 3 plus 4 is 7. You got 3 of those 7s, or a 21 for a sum. Do the same thing with the next one. This next one down here. Now notice we've got a different starting value. This time my starting value is 3. So I'm going to take 3, I'm going to put it everywhere I see a j this time. So my first term is going to be 3 squared. My second term is going to be 4 squared. My third term is going to be 5 squared. And I'm done because I've plugged 5 in and placed that thing. There's a 9 and a 16 and a 25. I think if you total that up, that's going to end up being a 50 for the sum of that particular sequence. So there's how you do it without your calculator. If you want to do it with your calculator, this is ultimately what you're going to do. You need to make your calculator say this: sum of a sequence of an expression followed by a variable followed by a start followed by a finish. So what does all of that mean? Well, the commas are actually going to be in there. So when I go to my calculator, and I'm going to show both the 84 and the inspire in just a second here, I want to find the sum command, I want to find the sequence command, I want to put in what the expression is in math terms, I want to tell it the variable I'm going to use, I want to tell it where I'm starting, I want to tell it where I'm finishing. So if I go to my calculator right here, and I say, all right, what are we going to do? I've already got this thing punched in. I've already done it on here. I've got sum, I've got sequence, I've got x squared, comma 1, comma 6, and I've punched it in. And we've played around with this a little bit, so if I have one punched in, so let's make the calculator do this now. If I want my calculator to do this, this is my inspire now. I'm going to hit my menu button, and on my menu button, you know what, let's make this a little bit bigger. So on my menu button, and once I'm in menu, I want to go to statistics. And in statistics, I am going to be looking first for the list math menu. Okay, now those of you guys that have an 84, this is going to play a role for you also. Whoops, I messed up here. Statistics, And I want, let's see, I want list math first. Sum of elements, number 5. Sum of elements. There's my sum. And then I want to repeat this thing, menu, statistics, list operations this time. And this time I want, whoops, did we not go into the right one? Sequence. I'm doing the sum of the sequence. Then I want to find the expression. So if I wanted to do that last one that we just had set up there, my expression, we were supposed to square j. Now I could do j. I'm not a big fan of doing j. You can do j if you want to. I'm going to make it x squared as my expression, followed by a comma. Uh-oh, where's the comma? The comma is its own button. Followed by what variable did I put in? Well, if I would have put in j squared, I would have used j. I'm going to put in x because I put in x squared. Followed by a comma. Where am I starting? I'm starting at 3, followed by a comma. I'm ending at 5, and I'm hitting enter. And there's my 50. If you did just a sequence, you'll notice what I have up here above on the page. If you did just a sequence, what it would do is it would actually show you what the numbers were that you added together. So there it is on the Inspire. What if we did the exact same thing on the 84? So on the 84, I want to do the same thing. So here's this 91 that I was playing with before I got into class. So 84 people, we're going to go into the list menu. So second button, list, second list. And I want to go to, first I want to go over to math, and I want to find my sum, which is number 5. And then I wanted to go into the list menu again, and this time I want to go to ops for operations, and I want to tell it sequence this time, which again is number 5. And let's put in our expression. Well, what are we doing? We're doing x squared, followed by a comma. Comma is its own button. Followed by the variable I use, which is x, followed by a 3, followed by a 5. And hit enter, and there's your 50. So on either calculator, it's actually very easy to do, and you're going to follow basically the same keystrokes. You just need to find it on either your Inspire or your 84. So there you go. So we got this thing set up. I think we've got a pretty good example of what we're looking at here. So now why are we doing all this? Well, if I have a calculator, a lot of this stuff's going to be nice. The problem's going to be when I have some generic things, maybe some variables, maybe some things my calculator won't help me figure out. Calculator will help you with numbers, but it won't necessarily help you with variables, and we might run into that a number of times. And you're going to have to be able to do this without your calculator, either on your AP exam or for me. So what happens if my counter is I, and it starts at 1 and it goes to n? Well, my first term would be k times 1. The second one would be 2k and 3k and 4k. And on and on and on until I punch in, whoops, sorry, not 4, until I punch in nk. Right? Or k times n, I guess, would be more consistent. Well, what do all those terms have in common? They all have a k in common, which would mean I could factor a k out of all of these. So what's the shortcut to all this? If you have a constant like this, you can take your constant out. This is the same thing as k times sigma I equals 1 to n of my sequence. So this is your shortcut. If you have a constant, you can pull a constant out. In the second one here, if you'll notice, you've got two different terms that are either being added or subtracted. Well, that means that you could take each of those two terms and write them individually and deal with their shortcut or deal with their summations on their own. So if you have a constant that's not related to your counter, you can pull that constant out. If you have multiple terms, you can create multiple sigmas. Then we get to some theorems here, and these theorems are going to be used to help us work these out when we can't put them in our calculator and we have to deal with some of these numbers. And I'm going to tell you that that's going to happen from time to time. So this first one, let's see, wait a minute. So my counter is 1. My counter is I. I'm supposed to start it at 1. So what's my first term? Well, my first term would be C. And then change the counter to 2 and plug it in place of all the i's. Well, there's no i's. My second term would also be C. What's every term going to be? It's going to be C. What's my shortcut? Take C and multiply it n times. Letter B, another shortcut. I'm just going to give it to you, and then I'll show you how it works. N times n plus 1 divided by 2. And the place I want to show you that this works, so now notice the counters, each of these four A, B, C, and D, they all start their I at 1. Which means if I starts at anything else, or J, or whatever your counter is, starts at anything else, this is no good. I want to show you how this works with that top example. That top example, let's see. If I went from 1 to 6 of I. So let's see. So according to this counter started in the right place. N is 6. So if I did N times N plus 1, 6 times 6 plus 1, all divided by 2. Let's see. 6, so that would be 6 times 7, which would be 42. 42 divided by 2 would be 21. There's two different ways to do the same thing. If you've got a very long sequence, this thing that's in black is a really nice way to do this. If you have a short sequence, like the way we did it in red, that's a nice way to do it also. Two more of them. The one for I squared is N times N plus 1 times 2N plus 1 divided by 6. And then the last one, if it's I cubed, N squared times N plus 1 squared divided by 4. Or for those of you who are playing along at home, it really looks like the one directly above it squared. Are we going to have to know those? Yes, you're going to have to. So do what you have to do to make it part of what you do, because you will need these. So there's some background knowledge on sequences and stuff like that, some shortcuts for sigmas. Let's use it for a few problems here, for a couple of quick problems, and see how things turn out. First one, if I equals 1 and N equals 10, let's put that 10 in. Let's put a 10 here. Let's put a 10 here. And let's use the shortcuts. If we use these shortcuts, well, what do we really got? We've really got the problem sigma I equals 1 to N of I plus 2 over 100. That's what I'm trying to figure out. Well, wait a minute. Let's think about every term's going to have a 100 in its denominator. So that's a constant. So let's take this 100 out. So what I really have here is I have 1 over 100 as a constant being multiplied by a sigma of I equals 1 to N of the quantity I plus 2. And I should probably be putting parentheses around these things. Well, now there's two terms. So how about if we treat it as two separate terms? So I have 1/100th times sigma I equals 1 to N of I plus sigma I equals 1 to N of 2. Well, now let's bring those shortcuts in. One of the shortcuts a second ago said if I had sigma I equals 1 to N of I is the one that we used, that would be N times N plus 1 divided by, oh, wait a minute, what's N? N is 10. Gosh, why didn't I put 10 in there in place of this N in the first place? I should have, I'm sorry. So there's a 10 everywhere we see an N. So this is really, let's see, how about 10 times 10 plus 1 divided by 2 for that first one, plus the second one is going to be 2 times 10 with a 1/100th out in front. So if you clean this up, what we've really got here, it looks like 10 times 11. And I'm going to tell you guys, go back to algebra when you think about this. This is really 10 times 11 divided by 2 plus 20. Well, 10 times 11, don't multiply 10 times 11. 2 is a 1. What we really have here is 1/100th of, let's see, that's 55 plus 20, or we've got 75 here, really, that we're multiplying by 1/100th. How about an answer to all this of 3/4? There's an example. What's in blue, you guys, is an example of what happens with shortcuts. The shortcuts are meant to make things easier so you don't have to list out 10 terms or ultimately more terms, because we're going to have a lot more than that. Number 2, let's go backwards. Now let's write this as a sigma. I equals something to something. I don't know what. We just have to figure out what it is. So let's look for patterns. Well, what do you notice? Every one of these things, every one of these terms has a 1 minus something being squared. So I'm thinking that my sigma is going to have a 1 minus something being squared in it, and I'm even going to put it in a bracket so it looks the same way. Well, even inside that bracket, it looks like the bottom of that thing has every one of them has a 4. The only thing that appears to be changing is the number that's on top of the 4. So if that's the case, where does I start? I starts at 1, and it goes to 4. There. I've written it in sigma notation. Number 3. Can you use shortcuts? You cannot. Why not? Because this case starts at 0. So if that case starts at 0, this is a great one to go ahead and put straight into your calculator. If I put it straight in my calculator, my expression, let's see, so if I did this, I'd be doing sum, sequence of the quantity 1 divided by k squared plus 1. Make sure you put the k squared plus 1 in a quantity, comma, actually, let's not do k. Let's call it x instead of k. X squared plus 1, followed by an x, followed by a 0, followed by a 4. And instead of busting out my calculator to do that, I'm going to let you do it because the problem I want to check on is problem number 4. So problem 4, here we are. This is why we did all this stuff. We've got 20 terms we're supposed to have listed out here. And if I have 20 terms, this is going to be a pain in my butt. So I'm going to start. I'd like to use shortcuts. Can I use shortcuts? Looks like I can. I start at 1 and I go to 20. So in this case, n is going to be 20. We'll keep that in mind. Can I use shortcuts for a quantity being squared? No, I can't. I need individual terms. So let's take I squared or I minus 1 quantity squared. Let's multiply it out. I'm going to multiply it out, and I'm going to make 3 sigmas all in one shot. I equals 1 to 20 of I squared. I equals, whoops, what just happened? Major technical difficulties. So sorry. I squared minus 2I plus 1. Well, let's go ahead. We were supposed to be doing sigma I equals 1 to n, or 1 to 20 of all of this. How about if we split it? Let's split it into 3 sigmas. Plus sigma I equals 1 to 20 of 2I, and my apologies, this should be a minus, plus sigma I equals 1 to 20 of 1. Well, now use your shortcuts. I squared shortcut, n times n plus 1 times 2n plus 1 divided by 6. There's your first one. Second one, well, wait a minute. This 2 right here is really a constant. So I'm going to take that constant in one little shot here. I'm going to put it out in front, and I'm going to multiply it by the shortcut of I equals 1 to 20 of I. That shortcut, 20 times 20 plus 1 divided by 2 plus sigma I equals 1 to 20. Well, that's going to be 1 times 20. Now all we have to do is clean up that line and we're done. Okay, so if I do that, let's see. I've got 20, I've got 21, I've got 41 divided by 6 minus here I've got 20 times 21. I'm going to cancel those 2's. I've got 20 times 21, and here I've got 20. So let's see. Don't try to multiply this out. Simplify it. 6 and 20 could reduce. 6 would reduce to be 6 would reduce to be a 3. 20 would reduce to be a 10. 21 and 3 would reduce. 3 would reduce to be a 1. 21 would reduce to be a 7. How about 10 times 7 times 41? 7 times 41 would be 287 times 10. This would be a 2,870 minus 20 times 21 is 420 plus 20. Negative 420 plus 20 would be negative 400. Add that to 2870. Negative 400 plus 2870. 2,470. Wow. That's the Sigma stuff we need. We are going to need this going forward. Spend a little time.